Hey guys, welcome back to another video in this Internet Basics section. We're going to cover a couple more subnetting examples for you today. Hopefully help solidify this principle in your minds so that you can use it when you're out there messing around with network stuff. So while we're going over these, remember our bit values that we've got within each octet are 1, 2, 4, 8, 16, 32, 64, and 128. We're going to be using those to help determine our increment and where our networks should begin. So to start off, we've got this example over here, or this problem I guess, which is subdivide 10.10.10.0/24 into 4 networks of equal size. First thing we're going to do is throw that subnet mask into binary, so it's a /24, so we know that we're going to have 24 ones on, and then the last 8 are going to be our host portion. So if we go ahead and use the equation 2 to the n, where n's the number of borrowed bits from the host portion, and then we use the fact that the increment is the last 1 bit in the network to determine the correct network IDs, we're going to be able to solve this problem. So 2 to the second is going to equal 4. That's what we want, is 4 networks of equal size. So we're going to go ahead and borrow 2 host bits. We add those 2 host bits to the original 24 that we've got right here. We're going to get a new mask of 26. These 26 network bits would look like this: 8, 8, 8, and then 2 in the last section. We go ahead and look at that final bit. It's going to be in the 7th position. Come over here, 1, 2, 3, 4, 5, 6, 7. That's going to give us this value of 64 for that last bit. That means that's our increment, or that's how much we're going to add to each network to get to where the next one will start. So that's going to give us 4 resulting subnets of 10.10.10.0/26, 10.10.10.64/26, 10.10.10.128/26, and 10.10.10.192/26. Remember, /26 is the same as this in binary, and if we go ahead and calculate out that last octet, we've got 1 in the 128 and 1 in the 64, so 128 plus 64 would equal 192. So if we were to write this in dotted decimal notation, we'd have 255.255.255.192. Now let's move over here to our second problem that we've got, which is if we start with the network of 192.168.0.0/24, we need to allot the 2 smallest subnets that will support 97 and 25 users at a minimum. So step 1, let's go ahead and throw that /24 mask into binary. Gives us 8, 8, 8, and then all zeros at the end. For this, because we're calculating hosts, we're going to use the equation 2 to the h minus 2, and then we'll go ahead and use the same last 1 on bit in the network mask to determine our increment. So if we were to try to borrow 6 host bits and do 2 to the 6 minus 2, that would give us a total of 62 possible users. And that's not enough to support those 97 that we want, so we're going to go up 1 and going to do 2 to the 7. That will give us a possible amount of 126 that will work for our first subnet. So that means borrowing those 7 host bits or reserving them as zeros, we'd do our 32 total bits minus those 7 host bits. That'll leave us with 25 left, or a /25 mask. Write that out in binary, we'd have it looking like this. We look at that last octet, or where the last 1 value lands, figure out our increment. That's in the 7th or 8th position of that last octet. Come over here, the 8th position has a value of 128. So that would mean that our next subnet is going to start at 192.168.0.128, because we add that 128 onto the beginning of this network, which started at 0. So now we've allotted that first subnet, we need to allot one for 25 users at a minimum. If we were to borrow 5 host bits, we could go 2 to the 5th, which equals 32. If we minus that 2, that would give us a total of 30 hosts. So that's going to work and be big enough. So we're borrowing 5 bits out of our 32 total bits. That's going to leave us with 27 network bits, or /27 mask. Write that out in binary, it's going to look like this. It leaves our last 1 on bit right here in this position, the third from the left. So if we go ahead 1, 2, 3, that means that 32 is going to be our increment value. So if we were to add another subnet on top of this, it would have to start 32 after the beginning of this subnet, which started at 128, and that would put it at 160. So our two resulting subnets that we would be able to create to hold these 97 and 25 users would be 192.168.0.0/25 and 192.168.0.128/27. You remember that /25 in binary would be the same as a 255.255.255.128 if we were to calculate that back out. And the /27 would be the same as 255.255.255.224. So those were a couple of subnetting examples for you. I am going to be putting some more subnetting examples in the link in the video description below, a little worksheet that you can work through. It'll also have some binary problems in there. And really important that you practice as much as you need to understand how to subnet, because the better you can do it, the better you're going to be at handling networks and understanding IP addresses and which devices would get which IPs. So feel free to take advantage of that and practice as much as you need to really get this down. I hope you stick around for the next video. We'll go ahead and go into a lab section where we'll subdivide a network out and we'll assign some IP addresses to two computers and make sure that we can get them to talk to each other. So I hope you enjoyed this video, and we'll see you in the next one.